everyone, let's see about Google Kubernetes Engine. It is another implementation from Google Cloud for deploying our application. Here we will be deploying our application as containers. Okay, container means I'll explain you each and every steps of containers. So container procedure is like, first we will create an image, then we will run the image, then the set of this process is called containers. Then we can move to how we can create an image. Okay, normally when you need to deploy a Java application, okay, for that the Java application should be visible to all the users in the world. Okay, for that you need a centralized server, right? So here in the server you will have an operating system. There you will have the dependency of the Java application like JRE, Java, and other libraries also. Then you will have your application code. Then for running your application, first we will run some main code, right? So that script also you need to start. So this entire package you need to deploy your application normally. So here what we are doing is, the entire thing we will be building a file. Okay, we can say it as a package. Okay, package also we can say it. So that package in Kubernetes world, we will say it as an image. So that's the main thing here. So when the image start running, so we will say that process as containers. So next is, this Kubernetes engine scales up application easily. Okay, when the containers goes down, it automatically brings up new containers and it is visible to everyone. The next is Kubernetes component. In Kubernetes component, the first we have is containers. Okay, containers means running of image. So for on top of that we will have a configuration called pod. What pod will do is, it will maintain the container. Okay, the pod will have some configuration like how the container should behave. For example, it will assign a port to the container, it will add volume to the container. So volume is like, in our container, our application is running, right? The application will generate some logs. So the log will be inside the container. So when the container destroyed or goes down, we are not able to take the logs after when container destroyed. For that, what we will do is, just imagine we have one drive. Okay, we will map that drive path to the container path where our logs is generated. Whenever a log generated inside the container, it will direct the copy of the log to the drive. So once this container goes down, the logs will be inside the drive, which we can take as a backup. Okay, that's the process of volumes. A pod is nothing but a YAML file. There we will add a set of instruction. Okay, like this the container should behave. Now the concept comes is, when this entire set like pod container went down. Now the thing is, what if this pod configuration went down? If the pod configuration went down, our users were not able to access our application. By keeping this in mind, the another configuration comes is deployment. Deployment will be on top of pod. Okay, how this pod is maintaining container, like that we will have a configuration called deployment. In that deployment file, we can have we can write to have n number of pods, like another one pod with our same container running, another one pod with the same container running. This first pod comes down also, these two pods will be running and serving to the user. So next comes node. So this on top of the deployment, another one configuration. So this is not a configuration, this is an actual server where we can run our entire deployment. Okay, I'll show you it as a demo, then you'll be easily understanding that. Node will be on top of deployment where inside our deployment is running. So next is cluster. Cluster is nothing but, we have one node, right? Inside the node our deployment is running. Like that we have 10 nodes. So that group of node is called cluster. So next is service. Service means this pod needs to be accessed from external world, right? Like user need to access our application. So user need a IP to access the application, right? That IP is assigned by this service. Okay, so these are the main concept of Kubernetes. Next is, what is the use of Google Kubernetes engine? In one of the video I mentioned the architecture of Kubernetes engine. Okay, when we install Kubernetes on our local machine, we need to maintain master node and worker node. So in Google Kubernetes engine, we don't want to worry about master node. We just use the worker node and we can deploy the application. Next is auto scaling and auto healing features. Auto scaling means if millions of users accessing our application, if the pods is unable to handle the request also, what Kubernetes engine will do is automatically assign n number of nodes. So n number of pods can be created and serving to our users. Next is self-healing properties. Self-healing means if the pod went down also, it automatically comes up. Next is monitoring, logging and security. So if our pod in the node means server, right? In the node, if our CPU limit exceeds or any traffic, incoming traffic, those related activity will be monitored and logged by Kubernetes engine. So next is, it can be easily connected to other Google Cloud services also. Okay, these are the main concept. So if you have any doubt in this concept, please mention in the comment section. So I'll be explaining it in very easy format. In next section, we are going to create a Google Kubernetes engine cluster and we are going to deploy the application. Yes, we can start this. So here you can see in the main page, there is a item called Kubernetes engine. So you can click this. Here you will see an option called create cluster. Then you will get two options like create as a autopilot cluster and switch to standard cluster. Autopilot cluster means we just need to specify the name of the cluster and the region. Okay, region where you can run, you can create this cluster. So you can click the create button. Other everything, it will be automatically happening. So the node creation, then the network for the node and other advanced settings like logging, monitoring, scaling, everything is set automatically by Google. When you switch to standard cluster, everything we have to do manually. Okay, here you see in first page, you need to give the name of the cluster, then the location type, that is regional or zonal. Regional means, for example, there are multiple regions like US, UK, then Europe, like that multiple region will be there. So in the multiple region, we will have subdivision like US 1, US 2, UK 1, UK 2. If you select regional now, it will create cluster in US 1, US 2, US 3. Okay. When you click zonal means it will create only in US 1 or US 2 based on how we say. You can define it here. If you click zonal now, we need to create US 1 or USB. Okay, this zonal is less price. So next is fleet registration. Fleet registration means Kubernetes is a tool, right? So every tool will have some upgradation, right? Whenever any update happens, so some components need to be added into the Kubernetes or some hot fixes need to be added into Kubernetes. Kubernetes will release some versions, right? That need to be updated in our cluster also. For that kind of information we require, right? So for that is this section. Next is node pools. Node pools requires here the number of nodes we need to give. So node means I already mentioned that is a server. Some of you are not aware of server means, just remember like it is a virtual computer. Okay, we are going to create a computer which the external, physical appearance we cannot see. We can only use the command prompt. Okay, you can see which computer we want, that information will be available here. So disk size, then the CPU size, memory size, everything will be available. And also we can select whether it is a Windows, Linux, Debian, that also we can select here. Okay, that also we can have an option to choose. Here you see Windows, Ubuntu, everything is there. Okay, so next is networking. So we can have networking options here. So for networking, I have made a separate video how subnets works, everything. So you can check it out. I am giving that link in description. Okay. So next is node metadata. Node metadata is used to tag the node with key value pair. Okay. We can take one node and we can add a key value pair, and in future if we want to schedule one of the pod to the specific node, now we will add some key value pair, right? Here you can see we will add some key value pair, right? We will give this value on the configuration file. Okay, then the pod will be automatically scheduled to the specific node. Next is tags. Tags means here also the same like node metadata. Here what we can do is we will create a specific tag. With using the specific tag, we can set some firewall rules to that specific node. Firewall rules, IAM rules. IAM, it is like a access management role. Okay, that means only specific user can access to that node. Okay, next is node times. So for example, if you are creating 3 nodes and one node, we don't have to schedule any pods. Here the concept is like when you are writing a deployment file and saying 3 pods need to be scheduled. Okay, now what happens is like Kubernetes will randomly assign pods to the different nodes. Okay, so now here the node times means what you can do is we have 3 nodes and one should not be scheduled, other 2 you can schedule. One, when we can use it, if the configuration file has similar values like the same key value pair I mentioned, right? Like that, here also we can create a key value pair, and only the configuration matches, it will schedule to the specific node. Now you can ask me the questions like, then what is this node metadata, then why we are keeping node times also? So I'll explain you that both. What is the difference? So for example, we have 2 nodes. First node 1, we have added node metadata key value pair. Okay, so in node 2 we didn't assign anything, it is staying idle. Fine. Then what happens is the deployment configuration is telling the few parts. Example, consider 4 pods. Okay, 4 pods need to be scheduled. So Kubernetes, what it will do is it will randomly add 1, 2 or 3 pod to node 1 and 1 pod or 2 pod to node 2. Okay, so these few pods are running in 2 nodes. Now what has happened is in the deployment configuration we didn't mention any of the pod to be running in the specific node. Like that, we didn't mention anything. Okay, so in next deployment configuration, and another one deployment configuration we are doing, there we are assigning this pod should go to only the key value pair created for node 1. Okay, then what will happen is Kubernetes will send that pod to the node 1 which matches the value, but this node 1 is already running with another pod also. That is not an issue, but the pod which has this specific value, it will come only on the specific node. Okay, now I think you may get the concept, but the concept in node time, it is not same. Okay, the node time, for example, now I have given 2 nodes, right? Node 1 and node 2. If you add node time to node 1, okay, if you write an deployment configuration and telling few pods to run, means Kubernetes, what it will do is it will keep the node 1 idle because we added node times. It will keep none of the pod will be scheduled on node 1. Only all pods will go and schedule on node 2. Okay, now if we create another one deployment, and in that deployment if the pod matches the node 10 configuration value, this key value and this effect, then that pod alone will come and run on node 1, then node 1 will get restarted. Okay, that's the concept here. So like the same, we have cluster networking, cluster security, cluster for, now we saw for node metadata. For cluster, the group of nodes, it will handle group of nodes, right? For that also it has metadata tags. Okay, then we can create our Kubernetes cluster.